It is time for the quotient rule. And then I'm going to quit for today, I think. Or maybe I'll do one more. I'm really not sure. Quotient rule is when you have one chunk divided by another chunk, and they both have to have letters in it. So there's two examples right there. Before you panic, realize that I will not be showing you an extended quotient rule. So this is the end of the big rules, although there's more stuff coming. So you have a function that's made up of a function on the top and a function on the bottom, and the rule for taking the derivative is to take the derivative of the top, multiply it by the regular original bottom, minus for quotient rule, which is why I kept saying product rule is plus. So minus for the quotient rule, take the derivative of the second, multiply it by the plain old first, and then put that over the denominator, the original denominator, squared. So I've written it here in English rather than mathy stuff. The derivative of the top multiplied by the original bottom, subtract the derivative of the bottom multiplied by the original top. All of that is in brackets to represent that it's all one contained unit, and then over the original bottom squared. So I've got two questions here, two on the next page. All of them are for no purpose other than to get you using the rules. So I'm going to put this over here, and I am going to do the side stuff again. So this is an f at x, so I have to use something else. So I'm going to use p at x to represent the numerator, and q at x to represent the denominator. And you'll notice that this one I picked and this one do not require a power of a function rule because there's no brackets with exponents. So the derivative of p at x, where did that come from? The derivative of p at x is equal to, drop the 2, keep writing, make it a 1. So that is 2x. And the derivative of q at x is 0 minus 2, so negative 2. So back over to this side of the page. F prime at x, but take the derivative of this using the above rule. Derivative of the numerator multiplied by the plain old denominator minus the derivative of the denominator, right there, multiplied by the original numerator over the denominator squared. So first thing is, you do not need to ever multiply this out. Second thing is, this is illegal. You cannot cross out part of it and not the other part. So you can't do that. So don't. What you can do is multiply this out and collect like terms. So 2x times 1, 2x times negative 2x, that's positive 2 times x squared, over, don't multiply this out, and to clean this up, 2x minus 2x squared over 1 minus 2x in a bracket squared. And then for some alternate answers, just for fun. As I said before, you can do some factoring. Sometimes it's advantageous and sometimes it is not. Here, this is totally possible, but not horribly useful. Another thing that you could do is you could turn this bracket around and do x minus 1, and that is basically eliminating a factor of negative 1. And you can't do that in the denominator because the denominator has an exponent on it. So these are all possible answers that you would have to compare to if it didn't match yours from the back of the book. So that is finding the derivative using the quotient rule. First example, remember that this is the slope of the tangent line. A general formula for it. Let's do a second question. So this one doesn't have f at x to start with, so off to the side, I am going to choose to let f at x equal the numerator and g at x equal the denominator. For this one, I'll finish the derivatives as I go. So there, and then g at x is equal to x squared minus 3x plus 5. And as I said a second ago, this is starting pretty simply because there is no power of a function on either the numerator or the denominator. So that's 2x minus 3. So time to do the overall derivative now that I've got the pieces for the question. Derivative of the numerator multiplied by the plain old denominator. Minus, because it's the quotient rule, the derivative of the denominator, which is there, multiplied by the numerator, which just coincidentally is the same thing, over the denominator squared. And again, you cannot cross out one of these brackets with one from above because that's illegal math. So now your job is to multiply everything out and collect like terms, but you have to be super careful. So 2 times x squared, 2 times negative 3x, 2 times 5, minus sign, and then FOIL. So unless you can run this negative through at the same time, I recommend you putting down a bracket and foiling. And as I said above, please do not bother multiplying out the denominator. There's no point to it whatsoever. So all this could have been done in green, going rogue. But I've decided to do it all at the same time. So 2x squared minus 6x plus 10. Run the negative through, so negative 4x squared, positive 6x, positive 6x, negative 9, all over x squared minus 3x plus 5 squared. And then collect like terms. So 2x squared minus 4x squared, negative 2x squared. Negative 6 and positive 6 make 0, plus another 6 makes 6x, and 10 minus 9 is equal to 1. So the part that I hate most about the quotient rule is that I just keep repeating the bottom, repeating the bottom, repeating the bottom until I'm done. And if you want an OR for this one, I could remove that negative from the top, which makes this a positive 2x squared, a negative 6x, and negative 1 over the same denominator. All right. So guess what comes next? My break. Also, power of a function. So I'm going to take a little break and get rid of this hand cramp. Judging from the frequency of my hand cramps, I'll probably need one after C and before D. So I've written down the f at x and g at x separate. I can use those because this says y equals. So f prime at x is equal to power of a function rule. Drop the 4. Keep writing. Make it a 3. Go inside, take the derivative of this, which is 4. So if I collect my monomials in multiplying, it's 16 times x minus 5 times 4x minus 5 to the exponent 3. So that is my f prime at x. So the derivative of the numerator. G prime at x is equal to, drop the 5, keep writing, make it a 4. Go inside, take the derivative of 3x plus 2, which is 3, and then again, multiply my monomials together, and you get that. All right. So time for the first line. Derivative of y, instead of y prime, I'll just fancy it up and say dy by dx. Derivative of the numerator times the plain old denominator. There. Minus, because it's a quotient rule, the derivative of the denominator multiplied by the numerator over the denominator squared. So that means I have to take 3x plus 2 to the exponent 5 and square it. Now, I normally wouldn't do that. I normally would put it over this, as in to the 10, because you multiply your exponents together. So I'm just showing my work a little bit here. So this one's going to take some common factoring. So if I dig out my red pen again, you are dealing with looking at this, which is in its most simplified form, and this, which is in its most simplified form. So if I compare the front and the back, I can't take anything out of 16 and 15 at the same time. But I do have a 3x plus 2 bracket in both the front and the back, before the minus sign and behind the minus sign. So I've got 5 of them here and 4 of them there, so I can take out the minimum amount, which is 4. And then I do have 4x minus 5. That bracket exists in both the front and the back. 4 here, 3 here, so I can take out the minimum, which is 3. And then here's my what's left. So the 16 is left. I've taken out this entire set of brackets. I've taken 4 out of 5 of these, so I need 1 more. Minus 15 will need to stick around. 3x plus 2 to the 4 matches. 4x minus 5, I need 1. So I'm going to leave this here temporarily. What you are allowed to do now that you've common factored, so not beforehand, but after you've common factored, because this is multiplied by this, which is multiplied by this mess, what you are allowed to do is you are allowed to take out 4 of these with 4 from the denominator, so that makes 6 of them. That is allowed because it's all multiplying. I'm going to take this space right here in green and multiply this out. So 48x plus 32, that's 16 times 3x, 16 times 2, negative 15 times 4x, and negative 15 times 5. So I'll have 4x minus 5 to the 3. My square bracket will turn into negative 12x plus 107, I think that is. All of that over 3x plus 2 to the 6. And that is the formula for the slope of the tangent of that curve, which of course you don't want to graph or do limits with. So let's look at that last question. I'll check my time after I do it for the first time. I may do it a second way. Let's make a new page. Bam. All right, so I'm digging at the black pen because this is not fantastic as it is. My change would be to turn it into y equals x plus 2 to the exponent 2 over x minus 3 to the exponent 2. To be perfectly honest, this is going to take the quotient rule, but if you wanted to, you could do the product rule by doing this. So that is an option with this question. So I'm going to do it from here. Dig out my green pen. I'm allowed to use f at x and g at x. So f at x is x plus 2 in a bracket squared, and g at x is equal to x minus 3 in a bracket squared. The derivative of this one, drop the 2, keep writing, make it a 1, go inside, take the derivative, and that's a 1. So to make this look prettier, we have this. And the same idea for this, it's still going to be a power of a function question. And if you're still struggling through that stuff, you need to make sure you're doing your work and asking questions so that it doesn't get too bogged down. So that's that, and I dig out the blue pen to put this all together in the quotient rule. So let's go y prime this time. So the derivative of the top multiplied by the plain old bottom minus, because it's quotient rule, derivative of the bottom times the plain old top all over the denominator squared. So because this is squared, I'm going to make that 4. Now, I've said before that you really should try to make sure your brackets are in the same order. I wouldn't say that it's so important that I need an extra line to write it down, because already I'm hand cramping, even though I didn't take my break. So there's the front half before the minus sign. Here is the back half after the minus sign. So I am going to common factor. So I'm going to take out a 2 from both of them because I can. A bracket of x plus 2 to the, here's 1, here's 2, minimum is 1. A bracket of x minus 3, here's 2, here's 1, so the minimum is 1. Bracket off what's left. So I've taken out the 2, I've taken out all of that, I've taken out one of the 2 of them, so I need one more, and I don't even need it in a bracket because it's at the beginning. Minus sign, I took out the 2, I took out, one of the 2 x plus 2's. This one does need a bracket because it follows a minus sign. My x minus 3 stays the same, and all of this is over x minus 3 to the 4. And because we've common factored at this point, I can take out one of those with one of those and leave 3 behind. So off to the side, x minus 3 x minus 3, subtract x, subtract 2. Multiplying through the negative means my x's will cancel out, and I'll be left with negative 3 minus 2 is negative 5. And the unfortunate part about this answer is I need one more line because I've got monomials to collect. 2 times negative 5 is negative 10 over times x plus 2 over x minus 3 squared. So we'll leave it at that. That's the slope of the tangent, or the formula for the slope of the tangent. There is some quotient rule information. This was smooth. Well, it was smooth for me. All right. See you soon.